Benzoic acid. Benzoic acid, the preservative that we use in food and drinks, such as diet sodas. I think maybe beef jerky might have benzoic acid in it. So you've eaten benzoic acid most likely before, and here is a jar of the solid benzoic acid. It's a white solid. Most organic compounds that are solids are white or yellowish. So here's benzoic acid. We're going to weigh out some and test its solubility in water, and then acidic and basic water. We'll start off by filling up a test tube. I've labeled properly. I put PHCO2H. That PH is for phenols, that's the benzene ring. And then the CO2H is this carbonyl carbon, 2 oxygens and a hydrogen. That's how you abbreviate it. So PHCO2H. I got benzoic acid, and I'm going to test just water. Got my initials and the date, so I need to put this into the scale and zero it. Got that beaker holding it. Hit the tare button. Looking pretty good. Fluctuates a bit. Not too bad. If I want, maybe try hitting it one more time. Alright, it's looking pretty good to me. And now I'm going to take it out of the scale to add the benzoic acid. I will not add the benzoic acid while it's in the scale, right? So if I make a spill, I prefer to clean up spills outside of the scale, not in the scale. And the worst case scenario is when things are spilled in the scale and then not cleaned, it could damage the scale. So here we go. We've got some crystalline benzoic acid. I'm going to add it to my test tube. I don't know if that's enough. Put it in a scale and check it. I want approximately 30 milligrams, which is 0.03. So about halfway, huh? About 15 milligrams, 15.5 milligrams. Okay. Let's take our test tube back out of the scale. Don't add it while it's in the scale. Try to get about the same amount. There we go. Add that to our test tube. Back in our beaker. Let's check. 0.341. I'll go with that. And remember, write these values down right away. 0.0341 grams. And you know what? I think you've seen me measure enough things. Believe me, I'll tell you the values that I get when I measure these. Will benzoic acid be soluble in water? Let's see. I've got my test tube with labels for benzoic acid and water, and I'm going to add approximately 1 milliliter of water. Initially, the solid's just floating there on top of the water. It does not look too soluble, but we got to give it a chance. We'll stir it up well. And I say maybe give it like 30 seconds stir. I'll fast forward the video, but here we go. Let's go. 1, 2, 3, 4, 5. Okay. I gave it plenty of time to dissolve, and it does not look too soluble. Yeah, it looks like it's not what I wanted to dissolve in that water. A lot of undissolved benzoic acid on the bottom. So I'm going to say it's not very soluble in pure water. Next up, 1 molar HCl, hydrochloric acid. The hydrochloric acid is mostly water still. It's an aqueous hydrochloric acid solution, so it's about 50-55 molar water. And 1 molar, not hydrochloric HCl, not HCl is a gas actually. It's not HCl, it's 1 molar hydronium and 1 molar chloride. So will there be a reaction between hydronium and chloride? So is that one of our big 4 reactions? Does hydronium react with a carboxylic acid? No, it doesn't. So we have no reaction. Now we're just really testing if benzoic acid is soluble in mostly water, which we already know the answer to. So let's see, I'll add about 1 milliliter of the 6 molar, not 6 molar, of 1 molar HCl, 1 molar hydronium, 1 molar chloride. And it doesn't look very soluble. Looks like it just floated to the top. But let's give it a fair chance. I'm going to stir it for 30 seconds again. So 1, 2, 3, 4, 5. So as predicted, there was no reaction. It doesn't appear to be a reaction occurred, and it looks like the benzoic acid once again is just not soluble in water, this is just mostly water. But move on. I want to teach you about pH paper. pH paper is great. It's this paper we can use to check the pH of aqueous solutions by color. So if the solution is acidic, it's on the pH 1 range, and it's a reddish, pinkish color. And then as it becomes basic, if you have a basic aqueous solution, it'll be at a blue range, like in the pH 10, 11, 12, around there. So let's check the pH of the 1 molar HCl. What pH should it be? Should it be acidic or basic? It should be acidic. So let's check it. Let's do it the proper way. So this pH paper, it's a little bit expensive. We don't want to waste it. We've got a big long roll of it here. What should I do? Should I just take off a big long strip and dip it in my solution? Should I take this long strip and dip it in the test tube? No, you don't want to do that. For 2 reasons. You don't want to waste it, and you don't want to put this in your solution. If your solution is important to you, it's going to leach some of the indicator molecules on the paper into your solution. So that's not the way we're going to do it. Instead of putting a pH paper in our sample, we're going to take a little bit of our pH paper, just a touch of it. So I'll just tear off just barely any. We can be very conservative with this. We can really make it last a long time. So I've got just a tiny piece of pH paper. I can put it on a paper towel. Then what I do is I get a spatula or a glass rod, and I dip that into my solution. This was the spatula I used to stir it. And when I dip it in, it's best not to just dip it quickly. It's best to swirl around and make sure you get a representative sample. Then when you come out, it'll be a little bit wet, and you can dip this on your pH paper when I find it on my video. We'll see what happens. It's turning pink. Actually, this bit of pH paper looks like it was oxidized or something. If you look at my strip here, it was it's not coming out well in the black background. If you look at it, see how it's kind of light? That part of the pH paper was outside of the container for a while. Let's try it on a piece of the pH paper further in that's darker orange, I'm sorry. So let's take and tear off this end. Okay, so then I'm gonna take just a little bit of that more orange pH paper, put it on the paper towel, and let's try this again. Sticking my spatula into the solution, not the pH paper, and then I'm gonna put it onto the pH paper. See, it should turn pink, and look at that, it turned pretty pink, right? Pinker than that one, huh? I'm gonna try to get a little more solution, heavy-handed with it. See, boom, yeah, there it goes. I'll do a little more here. So this one, that one's interesting. Looks like it got oxidized a bit being outside the container. It's been a while since we've been in lab, so this pH paper hasn't been used much. But that's how we use pH paper. A very small piece of pH paper, dip your spatula in the solution, then onto the pH paper, so the pH paper isn't being dipped into the solution. So yes, our 1 molar HCl is acidic as it should be. Now to test 1 molar NaOH. So the 1 molar sodium hydroxide is mostly water, it's about 50 molar water, and 1 molar sodium and 1 molar hydroxide. So will there be a reaction? There will be, right? So let me add a milliliter of this 1 molar NaOH, approximately. I don't have graduations on this test tube. That's okay. I'll eyeball it. I think that's close enough. And it's looking like it's dissolving. Let's stir it. 1, 2, 3, 4, 5. This does look like it's dissolving well, huh? I see a few specks stuck on the glass above the solution, but yeah, it looks like it dissolved. There's still a little bit undissolved. I think I could add a tad. This is definitely dissolving in 1 molar NaOH, and I'm going to add a little bit more. I think I was a little under a milliliter of 1 molar NaOH, so I'm going to give it a better chance. There we go. Yes, this looks like, it looks like the benzoic acid is soluble in 1 molar NaOH. We still have a little bit undissolved, but I think if I give it time, it will dissolve. But you could tell that almost all of it has dissolved. Now, let's check the pH of it like we did before. It should be basic, right? So what color should that be? It should be pink, not pink, but blue this time. So let me take just a small piece of the pH paper, tear off just a little bit of it. That's all I need, just that little bit. Put it on a paper towel, like so. And now I'm going to take my spatula out of the basic solution, and well, confirming that it's a basic solution. Put a little bit on my pH paper. Oh, look at that, dark blue, very basic. Looking good. So this benzoic acid is soluble, because you know already that's one of our big 4 reactions. Carboxylic acids react with hydroxide in water to become carboxylates with a negative charge, and that negative charge is like it's like you won the solubility lotto, the water solubility lotto, and all of a sudden you're so soluble that you dissolve in water, so the charge makes you so much more soluble. Now we're going to take this same test tube and change the pH. We're going to switch the pH on it. Currently it's a basic solution. Its pH is basic. So how are we going to change the pH of the solution? We're going to add HCl. Are we going to add the 1 molar HCl we used earlier on the sample? No, I'm not going to use the 1 molar. Instead, we're going to use 6 molar NaOH. The reason why, or 6 molar HCl. The reason why we're using 6 molar is because we want to change this pH quickly, not slowly, so that we can we don't have to add so much water. We're going to add I could change the pH by adding 1 molar HCl. It would take a long time. It would take a greater volume. As I keep adding more and more water, I'm going to be affecting things because I'm making the solution much more dilute overall. So I don't want to do that. I want to just add a small amount of liquid to change the pH. So here we go. I'm going to be adding my 6 molar HCl. I'm going to do it drop-wise. Let's watch carefully, see how it goes. So here we go. Here's 1 drop. I think I missed it. 1 drop there. Ooh, see that? How a precipitate formed. It's still there, but if I shake it, it starts to go away. Pretty cool, huh? Let's do another drop. Another drop of 6 molar HCl, which is 6 molar hydronium. Ooh, it turns, precipitate forms, I shake it, and it goes away. Awesome, huh? So let's check, actually let's pause at this point. And what I want to do is I want to check the pH of this partially acidified solution. So I take a little bit of pH paper, put my spatula in this solution. That's 1 molar NaOH sodium hydroxide with just a couple drops of 6 molar HCl. Let's see how it does with a new piece of pH paper. Still basic. So what's going on? What's going on is the inside of this test tube we have mostly water, and then we have sodium and hydroxide. The hydroxide is a much stronger base than the carboxylate, the benzoate. So when I add the HCl, it protonates the hydroxide and the carboxylate, but then the carboxylate gets deprotonated again by the NaOH that hasn't been fully quenched. So let's do it again. So I've got my solution here. I'm going to put another drop, 6 molar NaOH. Ooh, precipitate forms. Will it go away? Ooh, it looks like it's persisting. Let's do it again. Boom. Oh yeah, it's starting to stay now. Slowly but surely, another drop. This is maybe like 6th drop. Ah, look at that. Now, precipitate forms and does not go away. This tells me my hydronium I've added in the form of 6 molar HCl has reacted with virtually all of the sodium hydroxide. All of the hydroxide's gone, so now I have water and hydronium, and my benzoate gets protonated in this acidic solution. So precipitate is benzoic acid. So let me check the pH of it to make sure. So I'm going to take just the smallest bit of pH paper. There we go. And then I'm going to put my spatula in the test tube and swirl it around. Make sure it gets a nice representative sample. I don't want to dip it in just really quickly because then I might still have the basic solution from the last test. Okay, bring it back over to my pH paper, give it a touch, and I was a little slow about it. My solution's kind of thick and pasty with all that precipitating it, so I'm going to try something different than the spatula. I'm going to try a glass rod. So the glass rod I feel like will pick up more solution. I'm not seeing a big pH change. So maybe the solution's neutral. What would I want to do at that point? I'll just add another drop of the 6 molar HCl. Here we go. 6 molar HCl. 1 more drop. 2 drops. 1 drop, 2 drops. I actually added 3. So I've got some more HCl in there. I want to stir that around. Maybe I titrated this perfectly. I titrated it to neutral, which is very rare. Okay, so let's see. My solution should be acidic now, I believe. Let's check it. There it is. Now it's acidic. So yep, I was just a little short of acidic. I was titrating along. So now in summary, benzoic acid's not soluble in pure water. It's not soluble in 1 molar HCl. It was soluble in 1 molar NaOH when it was a basic solution. After I added this 6 molar HCl to acidify it, it became a precipitate, and it was not soluble, it precipitated out. So this happens a lot. The thing that just happened to me in terms of I thought I had made the solution acidic, but it wasn't. So that's why we always check with pH paper. If you're doing a reaction later in the semester and you don't check your pH with pH paper, you'll get a much lower yield. Because after I added a little more HCl at the end, I got more precipitate. So if I wanted to filter this off and I didn't check the pH, I hadn't added enough HCl, then I would lose my yield.